On this problem, we're looking to find the exact value of cosine of negative 5 pi over 12 using a sum or difference identity and or a symmetry identity. So there's a couple different ways to do this. All of them include looking at your unit circle. And I'm looking for, I could look for two numbers that have that when I add them together or subtract them, I get negative 5 pi over 12. So it would be helpful if these angles were expressed in terms of a denominator of 12. So for example, pi over 6 is 2 pi over 12. This is 3 pi over 12. This is 4 pi over 12. I don't have 5 pi, which is why we got to do this problem. And then we have 6 pi over 12. We don't have 7. We have 8 pi over 12, 9 pi over 12, 10 pi over 12, and 12 pi over 12. And I could keep going. This would be 14 pi over 12, but it's not really necessary since we're just trying to get to a sum or difference of 5 or negative 5. Another thing I can notice here is that I don't have to find a negative. I mean, I could. For example, we could do 3 pi over 12 minus 8 pi over 12. So that's one example. I'll go ahead and write that. So maybe our alpha and beta equals, I'll just remind you of that formula before we go on. So what we're looking for is using this formula, alpha plus or minus beta, and the sum identity is that cosine of alpha times cosine of beta, change the sign, and keep the function. So the sines are together, the cosines are together, and the sign flip and the plus minus flips. Okay? So that's our formula. So I just need to find an alpha and beta that gives me a sum or difference of negative 5 pi over 12. But I'll also notice that I could have also said cosine of 5 pi over 12 since these two things are equal by the symmetry ID. So if I can't find a sum of negative 5, I can always look for a sum of positive 5, and that will give me the same answer. I'm going to go ahead and do positive 5 since that's, I don't know, because it's right here and it pops out to me. So if I get 3 pi and 2 pi, I get positive 5. So one option for alpha is 3 pi, beta, 2 pi, and I could switch those since it's addition. Another option that you may have done on yours is alpha could be 3 pi and beta would be 8 pi. So when you do 3 minus 8, sorry, these should all be over 12. So when you do 3 minus 8, you get negative 5, so that would be another option. 9 and 4 will work too if I have, yep, so you could do alpha is 9 pi over 12 and beta is 4 pi over 12. So you can see there's a couple different ways to do it. I'm going to go with this first one that I found, and I'm going to use the symmetry idea to make it a positive 5 pi over 12 to do that. So then my cosine I will find of 3 pi over 12 plus 2 pi over 12. Actually, I'm going to back up a little. So I can recognize first that cosine of negative 5 pi over 12 equals cosine of 5 pi over 12 by the symmetry ID. And that equals cosine of 3 pi over 12 plus 2 pi over 12, which is this angle and this angle. So that really equals cosine of 3 pi over 12 is pi over 4, and 2 pi over 12 is pi over 6. Now, plugging these into this formula up here, I do cosine of both angles multiplied together. I change the sign. I was adding there, so now I'm going to subtract. And then sine of both those angles multiplied together. And then when I look at my unit circle, I see cosine pi over 4 times pi over 6 means multiply this guy and this guy. So that's a radical 2 over 2 times radical 3 over 2. And then for sine, I have this guy and this guy. So I have sine of pi over 4 is the radical 2 over 2 times sine of pi over 6 is 1/2. And that gives me radical 6 over 2 minus radical 2 over 2, which I can combine into one fraction of radical 6 minus radical 2 all over, that should be 4 and 4, I'm sorry. So when I multiply these fractions, 2 times 2 gives me 4. And this one, 2 times 2 gives me 4. So my denominator is 4. That's a final answer. So I will write that in my final answer box. Radical 6 minus radical 2 over 4. That is simplified and complete. Well, as a reminder, you won't have the unit circle given to you on the test. So my circling on this is kind of after I've already recreated the unit circle or thinking back to the unit circle.